But our second goal was to implement novel rehabilitation protocols. And so what we wanted to do is we recognize that in individuals who have ACL injury, we notice, and even based on a previous slide, that there's gait asymmetries. So one limb is doing one thing and one limb is doing another. And so that's a problem. And again, because of those imbalances, it leads to altered knee loading and knee osteoarthritis. So we started to figure out, well, how can we renormalize these patterns? And we pulled from people who've done work in stroke. And they've shown that if you do this asymmetric walking protocol, that they can actually restore healthy stride time dynamics, even in the short term, in response to having one leg going one speed and one going another. And so we do recognize that,
Oh, sorry. Oh, no, I was just going to say, it's like, I can tell you why this subject got injured. Your postdoc forgot to take the box off the head.
Yeah, no, I mean, they can't see.
That was like, that was only for the coordination test. Anyway, we all make mistakes as postdocs. Sometimes we forget to, attach the recording device or to hit record. Sometimes you just leave a box on the subject's head and they're uncoordinated. Yeah.
Well, and again, it's a visual thing, right? We detect it visually. But yeah, no, that was it was great. But the stroke, we recognize that the individuals with stroke don't have the same, people with stroke and people with ACL injuries are not the same population. They don't have the same injury, but we like the idea that we could renormalize gait. So that's what we sought out to do. So we did this investigation. We have this asymmetric walking protocol, and you can see we have a series of symmetric walking, and then we do our asymmetric where we kind of do a 0.25 difference for about 10 minutes, and then we have them walk symmetric pattern just as a washout period, and then we kind of go back and forth. So this is for us to see, is this even effective in this population? So that was really the rationale for this. So we go back to our AR triangles and we said, okay, we've defined our healthy region of dynamics. And then, okay, well, let's see what we have with this reconstructed individuals, ACL individuals. And again, fortunately for us, terribly for them, we found out that these people, even during symmetric walking, did not reside in this healthy range. So we're going, okay. Again, this is a very sensitive metric. It's picking up these subtle differences. But okay. But then we said, well, why don't we have them do our asymmetric walking protocol and see what happens? And I wouldn't be showing this slide if it wasn't good. But what ended up happening is we actually were able to kind of push these people into this healthy region. So that was really exciting because it allowed us to say that asymmetric walking does restore healthy ground reaction force peak dynamics in these individuals. So that was a really big finding for us. And, I was like, okay, this is good for the lab. We've kind of been struggling to get the lab set up and to get these people through here. And we were really excited to see that even in the short term, we were able to kind of move these people with this asymmetric walking into this healthy region. This was huge.
Yeah, Kristin, I actually just realized silly oversight on my part. I was looking at the AR, the AR regions, and basically just realized, like, okay, you're actually saying that for the healthy region, you're requiring that your second AR coefficient must be positive.
Mm-hmm.
Obviously, and that the first AR coefficient can be between about 1 and -1. So that one is allowed to oscillate between negative and positive, or is it right around 0? I was just wondering, can you actually give us a quick physiological description of what that upper triangle is meant to say?
Yeah. So, because you're right. I think on future slides, we talk about how specifically even in that lower region, you're really getting into the oscillatory dynamics. So you're seeing that there's kind of some underlying dynamics in this. But what we recognize in some of these regions is that they're in the non-oscillatory region. So that's one of the first things. So there is there's a pattern to it, but you're not seeing large deviations in this. But we notice as you get towards maybe to the right of that circle, you're seeing that people are, I'm trying to think of in our biomechanics standpoint, a more of a reserved conservative gait. So you're not seeing great large oscillations or large changes in their peak forces, not force. So you're not seeing these large oscillations in their dynamics. And so they're kind of having more of a stiffer gait. And so this idea of as they're walking, you're not going to see these large deviations in their peak ground reaction force patterns. However, if you're getting towards the edge of the triangle and you get towards that kind of outer region, you're still in the stable range. You're still in the oscillate. But what we started to recognize is that we saw that people's peak ground reaction forces, there was a lot of differences. If we think about, we have a first peak and a second peak. And what we started to figure out was that the magnitude between those was a little bit larger. And so again, it was less of a stiffer gait, but they were almost like struggling to kind of keep stabilized. So as they were getting towards that kind of outer band, we started to see that they were becoming a little bit more unstable. So we see that, again, moving towards kind of that 0 range, you were getting to more of a stiffer protocol, a stiffer gait pattern, and they were kind of minimize their, they were trying to minimize the dynamics or oscillatory patterns in their data. And however, as they got to the outer region, you started to realize that they really couldn't control these deviations. So that was more from a biomechanics standpoint. We had a kind of a stiffer gait, and then you were kind of saying these people are teetering on the brink of instability. They're going to completely go unstable.
Yeah, cool. Thanks. That's really helpful.
Okay. I know, hopefully. So then the next thing is we go, okay, well, let's kind of confirm whether or not we have our loading rate peak force versus loading rate dynamics. And again, we had people go at the symmetric walking. And so the symmetric walking was 0.75, 1.5. And then we wanted to figure out where our ACL individuals resided based on this 0.25 meters per second difference. And what they ended up is they actually, again, fell back into this region. So we were really excited because once again, it was telling us that we could actually restore healthy gait in these individuals. So again, asymmetric walking restores healthy motor control in post-ACL individuals. And I'm sure this is a bold claim, but we're going to make it and move on. But that was a really exciting thing. So again, we're continuing to show that this work is effective in getting people to exhibit more of their healthy dynamics. And then again, looking at our gait intervention, looking at our upon care plots, we remember that if we looked at symmetric walking, these individuals had their, the reconstructed limb was really having this splatter pattern. So we could really quickly see that it specifically because it was going perpendicular to this line of identity, that they were exhibiting kind of this really disruptive short-term dynamics, right? And so what we found is when they did the asymmetric walking is once again, we were able to kind of show that these people were starting to get back to this more oval pattern, which we know is really more associated with healthy dynamics. And we started to figure out that, again, while it's not, perfectly oval like it was in this heart rate variability, we were starting to see that they were actually getting into the more long-term dynamics of this individual. So they were starting to store these patterns in the more long-term. So that was the big exciting thing for this, is that our gait intervention was effective and actually renormalizing their gait patterns, again, their stride time patterns. So this was kind of, again, really cool. So, and what we liked about this is it really related back to this overriding muscle inhibition. So we talk about that they're not able to activate their muscles in the right patterns for either some reason. So it's clear that they have the ability to do so, but for some reason, they're not able to do it when they're doing the symmetric walking. So something about this asymmetric walking overrides this inhibitory muscle activation dynamics to get them back to this normal range. So that was kind of, a months and years of work whittled down, like you said, into 3 slides about how we can start to show that this novel gait intervention was really effective in restoring healthy gait dynamics in individuals.